Hey guys, welcome back to my channel, and today we are going to be learning how to deduce both the geometric and algebraic formula for the cross product of two vectors. So on the screen we can see both the geometric and algebraic formula for the cross product of two vectors a and b. Before we start deducing the formula for both, we need to first know the definition of cross product. So what is cross product? Basically, the cross product of two vectors A and B is a vector that is perpendicular to both with a magnitude or norm equal to the area of the parallelogram formed by these two vectors. Note that cross products can only be visualized in three dimensions in the real world. So we will be starting with the geometric one first. So let's say that we have two vectors A and B meeting tail to tail with one another at an angle theta. Their cross product would be a vector that is perpendicular to both of them. So we'll call this vector C. If we go back to our definition, you will notice that we mentioned that our vectors A and B form a parallelogram with an area equal to the magnitude of our cross product C. So using dashed lines, we will form our parallelogram. Since the magnitude of our cross product is the same as the area of the parallelogram, and we know that the area of a parallelogram is base times height, therefore, the magnitude of C is equal to base times height. And since our base is just the magnitude of vector A, aka the length of vector A, so we label this as our equation 1. The next step is to take out the right angle triangle in our parallelogram. The hypotenuse is just the length of the vector B, and what we want to do here is make our height h the subject of the formula. So using SOHCAHTOA, since we already have both the opposite and the hypotenuse, we use so sine theta is equals to h over the length of vector B. So we cross multiply, therefore making h equal to the length of vector B times sine theta. We'll label this as equation 2. So now we substitute equation 2 into our equation 1, therefore making the magnitude of our cross product C equal to the magnitude of both vector A and vector B times sine theta. So since this is only the magnitude of the cross product and it is a scalar, and remember cross product is always a vector, so we need to add a direction marker called the normal unit vector, which is represented as at n, in order to turn it into a vector and get our final equation. So this is how to find the geometric formula for the cross product of two vectors. Very fun and easy to do. Now, to deduce the algebraic formula, yes, I know what you're thinking. This formula is just way too long and it's not very easy to memorize. So, learning how to deduce the formula will make it easier for you to get the formula or even apply it to a question straight without having to memorize the formula. So now, how do we deduce the formula? Well, in order to deduce this formula, you must know how to find the determinant of a 3 by 3 matrix, which isn't hard at all. So we have two vectors A and B. And remember, cross products can only be visualized in three dimensions. So we are still going to call the cross product of A and B vector C. Don't forget to add the arithmetic signs on top of the standard unit vectors I, J, K. So we cross out the first row and first column of the matrix and put the remaining components into a 2 by 2 matrix and the unit vector I in front of it. Then we cross the first row and second column. We put this minus sign in front of the unit vector j, take out the remaining components into a 2 by 2 matrix. We do the same thing for k, cross out the first row and third column, put this plus sign in front of k and the remaining components into a 2 by 2 matrix. We multiply each component by its diagonal in the matrix before subtracting them. So we multiply a2 by its diagonal component b3. So we have I, open bracket, a2 b3. We then multiply a3 by b2 and subtract it from a2 b3. Then we close the brackets. We do the same for the rest. ijk just represents the x, y, and z axis respectively. We rewrite the equation as open square bracket a2b3 minus a3b2, comma. Using the minus sign in front of j, we open the brackets. We then have a3b1 minus a1b3, comma, a1b2 minus a2b1, close square brackets. So that's it. That's how you deduce the algebraic formula for cross product. Very easy. I suggest you practice it a few times just to fully understand it. If you enjoyed the video, give it a like and comment what you want to see next. In the next video, I'll be showing cross products in a 3D space with some real world examples. So subscribe and turn on the notification bell so you don't miss it. Um, yeah. Bye.